All right, now number 17. Whenever you're solving an inequality, it's going to turn out to be something that we graph on a number line. So we need to find the critical values that we will use on the number line. So one of the critical values will be the excluded value. So if I set the denominator equal to 0, that tells me that x cannot equal 3. All right, because that would make a 0 denominator. So that's my excluded value. That'll be one of the values on my number line. But also, the other critical value is the solution to the related equation 3x minus 5 over x minus 3 equals 4. All right, if I solve this, that'll give me another critical value. So there are lots of ways to solve this, but one way to look at it is think of this as 4 over 1 and cross multiply. So if I do that, okay, 4 times x minus 3, that's going to give me 4x minus 12. And then I set that equal to the other diagonal. 1 times 3x minus 5 is just 3x minus 5. So I see x's on both sides. Let's subtract 3x. So that'll give me x minus 12 is equal to negative 5. Now let's add 12 to both sides. So that'll give me x equals 7. That's another critical value. So I have x cannot equal 3 or x equals 7. So now let's go ahead and do the number line. All right, so there's my 3 and there's my 7. Now let's put some dots or circles here. X cannot equal 3, that's excluded, so we will definitely use an open circle to represent that boundary point. X equals 7, sometimes this will be an open circle, sometimes a closed circle. It depends on this. If we want to include the boundary, so we wanted the values that are greater than or equal to 4. So because we want to include the ones that are equal to 4, okay, then we'll include it by showing a closed circle. If this had just been greater than without the equal to, I would have made it another open circle. So I need to do some test values here. So I'll make a little chart. So I need to see where the solutions are. So I'm going to test values, like a value over here would be 2. So I'm going to check the value at 2. And in here, between 3 and 7, for example, 4. And to the right of 7, for example, 8. Okay? So one thing I could do is I could just substitute these values in and see, is it going to be greater than 4 or not? But sometimes what I like to do, let me just erase this for a second. Sometimes what I like to do is get 0 on one side and then just compare to 0. So imagine that I subtracted 4 from both sides. That would give me 3x minus 5 over x minus 3 minus 4 is greater than or equal to 0. All right, this is the form that I like to use the best, because seeing if something is greater than or less than 0 is very easy, just positive or negative. So I'm going to use this form. So I'm checking to see, is this value going to be greater than or equal to 0? You know, question mark. Now, if I'm feeling lazy or if I don't have a lot of time, I can use my TI-30XS multi-view. So again, let's turn on our calculator. I think I'll just reset this because I want a nice clear screen. So I'm going to type this in. Now remember, I moved the 4 over, so I'm going to type in this entire thing, including the -4. Okay, and again, I want to be in ask mode. Okay, so I need to check 3 values, 2, 4, and 8. So I can just type those in, 2, 4, and 8. And these are the values I get, -5, 3, and -1/5. Okay, so I had -5, 3, and -1/5. So, if these are true, then those will be solutions. So is -5 greater than or equal to 0? No. All right, that's a negative number. So there will be no solutions in this zone. Is 3 greater than 0? Yes. That means we will have solutions in this zone, which I will show by putting a line here. Is -1/5 greater than 0? No, that's a negative number. So we will have no solutions here. So this graph shows my solution set. Now in the end, I'm supposed to write this in interval notation. Alright, that means I'll start here with the 3. Alright, my solutions go from 3 to 7, so I'll just wind up putting 3, 7. I'll put a parenthesis on the 3 to show that it's not included, open circle, but I will put a bracket on the 7 because that's a closed circle, 7's included. So this would be the final answer. Alright, and that was number 17.